if you just simply assign a function to a variable, like how we do here, a function variable, now it is simply a regular function, right? But if you are passing a parameter, if you're passing function as a parameter to another function, now such functions are called as higher order functions. Okay, so higher order simply means that it is taking some function as a parameter. That's all, right? All right. Now, if you understand this syntax, okay, now there is the richness of Scala comes from the fact that there are some higher order functions which are available in Scala, which are very powerful, which you can use, right? So you don't have to write a lot of code for that, right? So some very useful higher order functions. The first one is what you call as map, right? So you need to really understand this well, because you'll be using a lot of these kind of things. Okay, so let me show you a map function, right? So a map function, okay, basically takes a function as a parameter to it, okay, and it applies this onto any data set which you are on which you are invoking this map function, okay, and it generates the results. Okay, so let me show you an example. So I want some data set here, so I'll say take some values from 1 to 9. Okay, so this is a range of data that you're creating, and on this data set, call the Scala's inbuilt map function. Okay, so Scala language provides you this map function. So this map function takes a function as an argument. Okay, now I'm going to create this function, which is a nameless function. Okay, so which is just an expression, which is an anonymous function. Okay, so here I'll say and I'll simply provide an expression here, which is 0.1. I'll say into everything. Okay, so observe the syntax over here, right? So if I do this, okay, now you can see that you have the result of this is basically a Scala collection, okay, full of doubles here. Okay, so it's basically a vector of doubles. So what am I doing here? So this 1 to 9 is a range of values. Okay, it's a vector from 1 to 9. Okay, now on this data set, I'm applying a function map. Okay, so this map is taking an anonymous function, which is defined here, which is simply an expression. Okay, 0.1 into now this underscore. This underscore actually represents every individual value of this input data that you have, right? So input data is a collection, okay, collection of values from 1 to 9. Okay, on each of those values, this function is applied, and this function is simply taking an expression. This function is simply an expression which takes, which multiplies every value. So this underscore here means this is applied. This is like a wildcard, which when you say like star, right? So on every value of this, right? So if you look at the result, so this is resulted in a vector or a as a collection, which has, say, this range of values is 1 to 9. So here you have 1 multiplied by 0.1, that is 0.1. 2 multiplied by 0.1 is 0.2, and so on. So it is up to 0.9. Now, similarly, there is another higher order function inbuilt in Scala, which you already used earlier. I think it is called as for each. Okay, so let me show you another example here. So I'll take the same thing, right? So I'll just take the same map here. And here I'll just tell, okay, now I'll say, take some string. So this is basically it was taking an integer, right? Sorry, this was taking a double. Okay, so now I'm going to put some string here instead. Okay, so in this function I'll put some string. Okay, and I'm trying to do this multiplication on this. Okay, now observe what happens. Okay, so you can see here. Now the result is basically a collection of this expression. Okay, evaluation of this expression. So I'm taking a string and I'm multiplying it with a integer here. So the result is basically the string is this particular string is represented that many number of times, right? So now, if supposing I want to apply another function on the output of this, right? So this is how the beauty of Scala, syntax is, right? So I'll take the same function, and I'm going to say dot. Okay, I'll say println. Oh, sorry. I want to print this results, right? So I'm going to say dot. I'm going to say for each. Okay, for each is another higher order function. Okay, so for each, and I'm going to pass a function into this for each higher order function where I'll say for each do a println. Okay, and I'll say space, and I'll simply put this underscore. So this underscore always gets applied on every value within the input data set. Okay, so here try to follow what's happening here. So I'm saying, see, this is my input data. On that I'm applying this map function. Okay, now I'm applying the for each function on this, the result of this set. Okay, so this gets evaluated first, and on the result of that you're invoking the for each function. Okay, so this for each function takes another function as a parameter. I'm passing the println function as a parameter to this for each function, and I'm saying underscore. So the result of this, which is nothing but this Scala collection, which is a vector of some strings here, right? So on this vector, it is going to apply the println function by using the for each. Okay, and so look at the results. Now what happens? Okay, can you see here? So since println simply prints whatever is the value that is passed into this println, so it is now sequentially it is printing each of those values. Now similarly, there is some more higher order functions already pre-built in Scala. Okay, for example, you can also use the filter function. Now let's take the same example. It kind of makes it easier. So you can use on this range of values, you can use the filter command. Okay, so filter again takes takes a function. Okay, now this filter function takes a function which basically results into a Boolean expression. Okay, so which means this function should return a Boolean, true or false. Okay, so the filter function applies this function on every values of the input data, and it returns only those values which which confirms it is true, or which is getting true for the function on the evaluation of the function that on applying the function that is passed as an argument to this filter. Okay, so for example, for this filter I'm going to pass an expression which will result into a Boolean value. For example, I will say take all these values, the input values, and make it divisible by 2. Okay, and if it is equal to 0, check if it is equal to 0. So this is my function. This is the expression I'm passing. So what I'm trying to do here, so this filter takes this and it applies it on every value. because I'm putting a underscore symbol here. So it checks every numbers in this range if it is divisible by 2, and if it is perfectly divisible, then it returns true for this, or it's going to capture only those, right? So if I do this, can you see here? Now within my result vector, I have 2, 4, 6, 8, which are all between 1 to 2. These are the ones which returns true when it is divisible, if it is divisible by 2. So can you notice a difference between a map function and filter function? So map also took whatever the function, it is applying it on the data set. Now the filter, see here in the map, whenever you use a map function, the number of values in the input and output collections will always be the same, right? So you get an equivalent output value. So that's the reason you call it as a map. So you're mapping input to the output using a function. Whereas filter takes in such functions which is going to result into a Boolean value. And if you notice here, the output will not be the same as that of an input. It can be lesser than or equal to input. There are some more functions like this, very interesting. For example, you have you can think of split function, right? So now let's say, supposing you have some string, right? I'll say Mary had a little lamb. Okay, now on this string, I'll use the split higher order function from Scala, right? So now I'll say split this, and you have to provide some delimiter, right? So I'll say pass this space as a delimiter to this. Okay, so here observe what it does, right? So basically the split function splits this input string right. Now there is also another function called sort. Okay, you want to sort this into with some order, right? So I can use this on this function itself. So on this result, I will say sort with, right? So sort with. Now here I need to provide some function or some criteria to sort with, right? So now here I will say sort based on the length. Okay, so I'll take I'll reference every element of the input here. Okay, and see, this is another logic you can think of, right? There's another syntax you can think of. So here I'll say length. See what is the individual element of this input to the sort. So the input to the sort is the output of this split function, and the output of the split you know that it's an array of strings here, right? So this array of strings have individual strings in it. So these strings become the input to the sort with. Okay. Now here what I'm doing is when I put this underscore, okay, it means that it takes every values. Every value in this array, right? So and it is referring that, and it is getting the length of it. Okay, and I'm checking that if it is greater than. Okay, now I put this again. Length, right? I hope the spelling is correct. Length, yeah, right. Okay, so now if you observe, the length function for the string type gives you the length of the string. Okay, now so basically I'm taking every element of this array and I'm looking at the length. Okay, and the sort with, I'm saying sort with in such a way that every element's length compared with the, I'm putting this again, this underscore. So the second time I put an underscore in the same expression, what it does is it applies this on the next consecutive element. Okay, so in this case, in the first hop, what the sort with will do is it will check the the first element is Mary here, so it will find the length of this Mary string, and then it compares with the length of the next consecutive element. Here is had. Okay, so it compares it with had, and then so I'm saying if the first element must have a shorter length when compared to the second element. So that is what I'm indicating to the sort with function here. So it checks the first element's length and then the next element's length, and if so it rearranges this. The sort with is rearranges this based on the length. So it pushes the the element which has shorter length ahead of the one which is having the longer length, right? So, and it does this for every element. So what happens is now in the second hop, it swaps basically Mary and had. Okay, so had goes front, and so now you have Mary in the as a second element. Okay, in the second round, the second element, so it applies on the second element and the third element, right? So similarly, it sorts it based on this. So where the first element should have, should be less than the second element's length. Okay, and if you observe here, now, as a result of this sort, you see now the same array has, the data rearranged based on the length of the individual values here. So this array has got sorted, right? So the point to observe here is when you use two underscores in the same parameter, so sorry, in the same function or the same expression, the first underscore will get the the first value, and the second underscore will get the next consecutive values. Scala is a pure object-oriented programming language and a pure functional programming language, right? So everything is actually a function and objects, right? Now, for example, in a functional programming language, now supposing if you have, say, something like this, right? So if you want to if you want to compare to strings, you do not want to redefine, keep defining functions all the time, right? So for example, if I have a something like this, right? Okay, so here what is this doing? So this is a function, okay, which doesn't take any parameter, okay, and it is returning a string called str. Okay, or I can say let me not confuse you. I'll say ABC, right? So this is a function which returns some string, right? Now this println function, okay, now I'm passing this function str to it. Okay, now you can see here it returns ABC, right? So instead of trying to do this weird way of defining a function, which is which is a tedious process, every time you have to keep doing this, right? So instead you can simply say println of ABC. Is it not? So both returns the same thing. So it has the same impact here. So you can think of, see, when you have something like this, so if you observe here, now when you say pass this string like this, okay, so this is do you agree that this is same as defining a function which returns this and passing that as a function here? So both of these are equivalent, right? So here this is possible because, see, strings exist as literals, right? And analogously, the functions also are literals, right? So therefore, you can actually write functions without the need for having this sort of a structure here, right? So therefore, functions which do not have any name, okay, so these are called as anonymous functions,